Hi guys, so this is our first video on differentiation under math studies. We are going to start in this video with the very basic concepts of differentiation. We shall tackle the 4 questions that are on the screen in front of you, and I shall begin with question 1 shortly. So question 1 came in paper 1, November 2009, question number 6. Kindly take a minute, pause the video, attempt to solve, and the answer shall follow through shortly. So this is a very simple differentiation problem. You are given the following function or equation, 2x squared plus x minus 6, and in question A you are required to find f dash, and you should know that f dash is the derivative function of f of x. So basically you are being asked to differentiate this function, and the very simple, very basic rule of differentiation is that we reduce the power of the variable by 1. So in the first term I have 2x squared, so I'm going to reduce the power by 1. So x power 2 becomes x power 1. But before I do so, I shall multiply my expression by the old power. So the old power was 2. So as you can see, I've multiplied my expression by 2. So you first multiply by the old power, and then you reduce this power by 1. This is for the first term in my function, which is 2x squared. Next, I want to differentiate the x, and you should know that x is actually x power 1, so that just becomes 1, or 1 x power 0, and x power 0 just vanishes. Finally, for my third term, which is negative 6, I don't have a variable to differentiate, so the entire term vanishes. So this is very basic. You should have an adequate understanding of basic differentiation before attempting past paper problems. So you should consult a textbook if this is not the case. Now I'm going to simplify my blue function. So 2 times 2 is obviously 4, and x power 1 becomes x. So I get 4x, and the 1 remains as it is. This is my final answer to A. Now in question B, I'm required to find f dash of negative 3. So what is f dash of negative 3? It is the value of the function f dash of x when x equals negative 3. So I replaced this x with negative 3. So to evaluate that, I shall replace all x's in this equation with negative 3. And I only have one x. So this becomes 4 times negative 3 plus 1. And if you evaluate that manually or using your GDC, you get negative 11. Now in question C, you are asked to find the value of x for which f dash of x equals 0. So this is also quite straightforward. I'm going to set f dash to 0. What is f dash? As we got in A, f dash of x is 4x plus 1. So 4x plus 1 equals 0, and I solve that to get x equals negative 1 over 4. This is the end of the first question. Pause the video, take a minute to write the answer down if you will, and I shall begin question 2 shortly. So the second question that we shall tackle in this video came in paper 1, November 2014, question 15. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, you are given this equation, y equals x squared plus a over x minus 1, and you are required to find dy by dx. Or in other words, you are required to differentiate y with respect to x. Or you are required to find y dash, the derivative function. These all mean the same thing. So I'm going to begin differentiating, and here is a very important hint with regards to differentiation. If you are given a term like the middle one right there, where x is in the denominator, you need to sort of change your equation a little bit before differentiating. So you will notice that the red expression right there is not the differentiated function. It is actually the original function. I've only changed one small detail in this equation, which is the second term. Instead of having a over x, I've rewritten this as ax to the power of negative 1, because this helps me differentiate. This makes differentiation easier. So whenever you have an x or an x squared or an x cubed or an x to the fourth power in the denominator, you raise it up and you switch the sign of the power. So instead of a over x, I get ax to the power of negative 1. This will help me with the differentiation. So again, the red expression is still y. I have not yet attempted to find y dash. I shall do so in the blue equation right there. So dy by dx, or y dash, is the derivative of the red expression. So let's start differentiating. The first term is x to the power of 2. This is my first term that I shall start differentiating. I shall reduce the power by 1, but first I shall multiply by the old power. So I get 2x power 1, or just 2x. For the second term, I have ax to the power of negative 1. I shall begin by multiplying by the original power. So negative 1 times a gives me negative a, as you can see. Next, I shall reduce my old power by 1. So negative 1 minus 1 gives me negative 2. So I get negative ax to the power of negative 2. As for the third term, it is a constant. I do not have a variable, so it just vanishes during differentiation. Hence, my final expression is 2x minus ax to the power of negative 2. Next, I am given some important information before attempting to solve B. I'm given that the gradient of the tangent to the curve is negative 14 when x equals 1. So let's translate all of that. You should know that the gradient function is the derivative function. So whenever I'm talking about the gradient, it should immediately come to my mind that I need to use or find y dash. Thankfully, we've already found y dash in question A. So when x equals 1, so this should give me a hint that I shall substitute x with 1 in my blue function, which is y dash. So I shall get y dash of 1, or f dash of 1. What does that mean? It means that I shall evaluate the blue expression, but I shall replace the x's with 1. So I shall get 2 times 1 minus a times 1 to the power of negative 2. 1 to the power of anything is 1, so I just get 2 minus a. So what else am I given? I'm given that this gradient is negative 14. Hence, y dash is equal to negative 14. and I have evaluated y dash to be 2 minus a. Hence, I know that 2 minus a equals negative 14. This is a very simple algebraic equation. I shall solve it to find the value of a, which is what the question requires. Hence, the final value of a shall be 16. So this concludes our second question. Pause the video to write this down if you will, and I shall begin the third question shortly. So the third question that we shall tackle in this video came in paper 1, May 2016, time zone 1, question number 11. Kindly take a minute to pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, you are required to find f dash of x given the function f of x equals ax squared plus c. This is a straightforward differentiation problem. Let's go through it quickly. As we said before, we multiply by the old power, so we get this 2 right there. Then we reduce the power by 1, so x squared becomes x power 1, or just x. Hence, ax squared becomes 2ax. You shall notice that the a does not really affect my differentiation because it's a constant. It's like 5 or 4 or 3. But instead of multiplying the 2 by a number, I'm just going to multiply the 2 by the a. So I'll just get 2ax. As for the second term, which is c, c is a constant. So when I differentiate, it vanishes. Again, just like 4 or 5 or 3, as you saw in previous problems, when there is no variable and I differentiate, this term vanishes. So this is the solution to question A. Now, for question B and C, I'm given some important data that I shall use. I'm given that I have point A with coordinates negative 2 and 5. This means that when x equals negative 2, y equals 5. So how does this help me? If I plug negative 2 into the original function f of x, in other words, if I attempt to get f of negative 2, where I replace the x with negative 2, I shall find that the answer has to be 5. So this is what I get from the first given, which is point A, with coordinates negative 2 and 5. The second given is that the gradient of the tangent to the graph at A is negative 6. So at A, or when x equals negative 2, which is the x coordinate of A, we know that the gradient is negative 6. In other words, y dash has to give me negative 6. Or in a third way of describing this is that f dash of negative 2 equals negative 6. So how does this help me? I already have f dash of x, which is 2ax. So if I substitute negative 2 into this red equation, instead of x, I shall get negative 6. And this is what I did in the equation in gold. This is basically a substitution of x in the red equation with negative 2. Then I equate to negative 6 based on the blue equation right there. So I get negative 4a equals negative 6, and I solve for a, getting 3 over 2. So I started with the second piece of information, which is the gradient of the tangent, because this helped me immediately to find the value of A. Now, forgive me, there is question C here. This is a mistype. So, to find the value of C, I shall use the first piece of information, which I have not used yet, which is the green equation. F of negative 2 equals 5. Now, f of negative 2, as we said, means that I'm going to substitute the x with negative 2 in the original function. But the addition here is that now I have the value of a, which is the 3 over 2 I got in the previous question. So I'm just going to rewrite f of x, but with my new information. So instead of this a, I'm going to write 3 over 2. Instead of the x squared, I'm going to write negative 2 all squared, because I know that I am required to find this information at point A, where x equals negative 2. So I'm going to use the x value of point A. Finally, plus c remains as it is, and I know that when x equals negative 2, f of x, or in other words y, equals 5. So how do I know that? I know that from point A. Point A tells me that when x is negative 2, f of x equals 5. Hence, I get this green equation right there, and I simplify to get 6 plus c equals 5. Hence, c equals negative 1. So take a minute, pause the video, take a look at the answer, and maybe write it down if you will. This concludes our third question, and I shall begin the fourth question shortly. So the fourth and final question to be tackled in this video came in paper 1, May 2013, time zone 2, question number 11. Kindly take a minute, pause the video, attempt to solve, and the answer shall follow through shortly. So in question A, you are required to find f dash of x, the derivative function of f of x, which is 3x minus 2 over x squared. As we mentioned in question 2 in this video, whenever I see a variable in the denominator, regardless of its power, whether x or x squared or x to the power of 5, I shall first rewrite the function before differentiating. So the black function is the original function as given in the question. The green function is still the original function. I have not differentiated yet. However, I've rewritten the function in a friendlier form. Instead of 2 over x squared, I shall rewrite it as 2x to the power of negative 2. This shall help me with the differentiation process. Now, the differentiation is basically what I did to go from the green function to the blue function. So let's check this out. I have 3x here. So 3x becomes 3 because x power 1 becomes x power 0 and vanishes. For the second term, I first multiply by the old power. So negative 2 times negative 2 gives me positive 4. And I reduce my power by 1. So negative 2 minus 1 gives me the new power of negative 3. Hence, the answer to question A is 3 plus 4x to the power of negative 3. Now, in question B, I'm given that the gradient of the curve at point A is 35. And we said before that whenever I see gradient in the context of differentiation, I should immediately think of f dash or y dash, the derivative function. So since the gradient is 35, I conclude that f dash of x equals 35 at this point. And I'm required to find the value of x at point A, excuse me. So f dash equals 35, hence this blue expression equals 35. So this is what I've written right there. 3 plus 4x to the negative 3 equals 35. Now, in order to solve this, you can either do it manually or you can do it using the GDC. I shall use the GDC because it is simpler and faster. In order to solve any equation, I should first rewrite it as an equation that equals 0. So to go from this purple equation to the dark blue equation right there, all I did was I took the 35 to the left hand side and changed its sign. So I have 3 plus 4x to the power of negative 3 minus 35 equals 0. I can easily solve this equation using the GDC, and you shall see how to do that right now. So here is my GDC. I shall first go to y equals, the button at the top left, and I shall press on it like this. Then I shall write the equation carefully. I want to solve the dark blue equation right there. So I'm just going to write it down very carefully. So, as you can see, I've written down the equation exactly as it is. And I'm going to click on the trace button, which is right there. So, as you can see, I have this function drawn on the calculator. I want to find the value of x for which this function equals 0. So in order to do so, I shall use a specific calculator operation that helps me do that. I shall click on second and then trace to get the calculator functions, and I shall click on 0, which is the second operation. I'm required to identify the left bound, so I'll just click enter. Right bound, so I'll click enter and guess. So I am told that y equals 0 when x equals 0.5. Hence, my x coordinate is half. And this concludes the fourth question and the entire video. Take a minute to write this down if you will. I hope you have found this video beneficial.